Hey everyone, it's Colin. How's it going? Not too long ago, I uploaded a video giving a quick tour of some really old, big, expensive servers that I had recently decommissioned at work. And I was really surprised by the reaction to that video. There were lots of really good questions down in the comments. So this time, let's go through and answer them. Alright, so if you haven't seen that episode, I'll have a card up above and a link down in the description. It's probably worth a watch before you get too deep into this episode. But basically, it was a tour of two different models of servers that I had recently decommissioned at work. An IBM X5 series and a set of Hewlett-Packard DL580 Gen 7s. They were used in kind of a cluster for virtualization, and I had simply replaced them with brand new hardware at the time, so those were the old boxes that came out. Lots of really good comments on that video from people who have similar jobs and have worked with similar hardware, so kind of a lot of camaraderie going on in that in the comments of that video, but also a lot of really good questions, not only from people who work in IT asking why I did things the way that I did them, but also from people who aren't really all that experienced with servers, but just found that video and the content itself really interesting, asking some very good questions. A lot of them I didn't really get into in the video itself. I wanted to keep that video moving and keep it more focused on the hardware and not so much kind of the concepts of running servers and the way they're architected and all that. But I think maybe this is a good opportunity to get a little bit more into that side of thing, and then also explain why they were being used the way they were being used. So, the first and perhaps most frequently asked question was simply people wanting one of them. What am I going to do with those servers? Am I going to throw them out? Is there an opportunity for people to buy them or buy parts from them, that sort of thing? And the simple answer is no. Unfortunately, they are not mine. I don't get to do what I want with them. They belong to my employer, and we're actually going to be keeping them. They're going to sit as like shelf spares in storage. Because one, even though they are older servers, they are still usable. I mean, they were in a production environment up until the day that I decommissioned them and pulled them all out. So, you know, they were still working and usable. And then also because I still have a DR, disaster recovery site, and several similar servers at that location to kind of cover as backup should something dramatically fail at my main site. So I've got similar servers elsewhere. These could prove to be really good kind of backups or replacements for those should I need them, or should some special project arise where I temporarily need some servers to set up and use, and it doesn't really warrant going out and buying brand new ones. So they still have some life left in them, and I'm kind of hesitant to sell them right now just because they're still worth something to me and my organization. But after probably another year or two, we'll end up likely selling them on to a recycling company. Not necessarily to like scrap them and shred them and turn them into, you know, raw materials again, but rather there's a pretty robust kind of like used IT equipment ecosystem out there of people who don't necessarily have the money to buy brand new equipment all the time, or people who need to keep nursing older equipment along for whatever reason, long after the manufacturers stop supporting that hardware. This kind of third-party, you know, used hardware marketplace ecosystem thing really kind of fills in those gaps and can prove very competitive when it comes to pricing if you need a part off of an older system or something like that, rather than just like trolling through eBay and trying to find something. So chances are that's where we'll end up selling those systems onto eventually. Like I said, in a couple of years, it's not really all that kosher for us to be just taking stuff home. There's all sorts of crazy like accounting and processes and like other rules and stuff. But anyway, sadly, no, I can't like do a big old server giveaway or anything for the channel. They're going to be in storage for a while, but it's okay. No big deal. That also then leads into probably the next most common question. And that is, why did I even decommission them? I mean, I mentioned in that video, those servers were from like 2011 to 2012. Why decommission servers that are like, only 5 or 6 or so years old? When like regular PCs, there are people out there who have laptops and desktops that are even older than that, and they're still usable. And especially considering there was really nothing wrong with the servers that I decommed. Like, why give them that short of a life? And there's a couple of really good answers to that. The first one is really, it comes down to reliability. In IT, and especially with some kinds of parts, but it really, I think, falls along a lot of them, there's this concept called the bathtub curve. And it's kind of like a predictive analysis of when parts in systems are going to fail. It really just kind of boils down to this: the highest chances of a part failing, or when the highest chances of a part failing, is generally at the very beginning of its life, like when it's brand new, and they call that infant mortality, or after a certain number of years, when that particular part or system has been in production and used for quite a while. It's got some wear and tear. Maybe it's got some power cycles on it. Maybe it's been physically moved around a bit. So, it might get a little rattly or whatever. After a certain number of years is when the likelihood of part failure starts to go back up. And it's going to depend on the kind of part. Traditionally, the bathtub curve is most commonly associated with mechanical hard drives, but generally it's often the case with a lot of different parts, power supplies and motherboards and fans and other components as well. It may seem like 5 years, 6 years is a really short life for a server compared to a desktop, but you've got to think about what the actual use case and workload and failure mode of, let's just say, a regular, workstation, a desktop is going to be. Well, so the use case is going to be, it's just a computer for a single person to use. And the workload is going to be not necessarily like full steam all the time. On a regular PC, the workload is going to be very periodic. There are going to be times where that computer is sitting there doing nothing, and other times when it's doing some work, but in relatively short bursts, right? And couple those two together, the fact that it's not used all the time, and chances are there's only one person using it, because like if it's your computer at home or even just your laptop for work or whatever, you're probably the only person who use it. It's not like you've got hundreds of people who need to share that one computer. If it fails, the scope is relatively limited, right? Like if your computer fails at home, yeah, it sucks, right? But you're really the only person who's impacted by that. It's not like you've got an entire company of people who are down. It's not like you've got, customers who can't buy your products or something like that. If a workstation fails, if a laptop fails, it's not the end of the world. And also because those machines are generally a bit more commodified, you can go out and buy parts or just buy a complete replacement one like off the shelf relatively quickly, within the span of hours. Drive to the store, go buy one, or, Amazon Prime Now or whatever. You can get back up and running in pretty short order. When it comes to servers, though, that's a completely different beast. You think about servers, and it's very rare when a server handles work for only one person. Generally, it's a shared resource, especially when you start looking at servers that run virtualization software like ESXi from VMware, which is what those old servers that I decommissioned ran. So you've got a whole bunch of people that rely on services that those servers perform. And generally, it's going to be a 24/7 kind of work cycle, especially these days when you've got companies with branch offices that are potentially all around the world, and people working from home, and people working different hours, different shifts. It's not necessarily all that fair to say that the majority of servers sit there and only need to get used 9 to 5 during the week when people are physically in the office. It's increasingly that servers in general need to run 24/7, 365. And if one of them were to fail, chances are that's going to impact more than just one person. It's going to impact a lot of people. Of course, it depends on the workload that the server ran, but if it's something like your company's website and the server dies, well, that's kind of a big deal. If it's your company's email server or domain controller or some other services, something related to the ERP, suddenly that thing fails and, oh geez, now, they can't run payroll or something like that. It's kind of a big deal. A lot of people get impacted by it. So in IT, generally servers need to, one, be built to be more reliable, which they generally are. They use higher quality parts and they build in redundancy where they can. Like I showed in that video, redundant power supplies and redundant fans, and you can put multiple hard drives in and do RAID arrays with them. In some bigger systems, you can even do rating of RAM, which is kind of a mind-blowing concept. Like you can take multiple sticks of RAM and have them basically contain the same content so that if a single stick of RAM were to fail, it's not a debilitating thing, like the server keeps going. But in addition to that hardware reliability, you also have to look at it from the support angle. And this is arguably where a lot of server manufacturers make the bulk of their money. It's not necessarily on that initial upfront cost of the server. I mean, yeah, servers are fairly expensive when you buy them. We're talking thousands of dollars and not like $600 like you'd pay for a laptop. But it's also the service contracts. It's if something fails, you can call that company any time of the day or night and talk to a human being who will help you troubleshoot what the failure is, sometimes regardless of whether it's hardware or software. And then it's also parts availability. A lot of service contracts come in tiers where they give you that phone support piece where you can call them up and, if you need help, if you're not sure what part has failed or whatever. But there's also how fast do you want to get a replacement part? And then are you capable of swapping that part yourself, or do you need somebody else to do it for you? So oftentimes you'll see difference in prices with just basic service, as in we'll overnight you a replacement part. You'll have it the next day and you need to install it yourself. And in those cases, for the majority of servers, that's what they call an advanced replacement. You don't have to take the old dead part out first, ship it to them, wait for them to get it, and then they send you a replacement. If you're paying the kind of money that you are for a real server, they're going to give you that new part first and then wait for you to send the old one back after, just to get you back up and running quicker. But you can go faster than that. If overnight shipping isn't good enough, you can get to 4-hour shipping, in which case typically it's going to be like a depot or warehouse in the same state or in the same city where you are that has a stock of all those parts. And if one were to fail, let's say a power supply in a system were to fail, you call them up right away. They'll have a courier go to that warehouse, grab that part, and drive it straight to you. And they give you like a 4-hour guarantee, in quotation marks, as to, that's how quickly you'll get it. Sometimes you can also pay extra if you need a technician to install that part. Maybe it's a complicated server, or maybe you have staff at your work that knows a lot about software, but not quite so much about hardware, and they're not very comfortable working inside servers, taking them apart and troubleshooting and all that kind of stuff. So sometimes you can pay extra for service contracts where a technician will be sent along with that part, and they'll physically do all the work and confirm the server's up and running again. Those service contracts cost a lot of money. We're talking a couple $1,000s a year per server. And those prices go up over time because, one, server manufacturers want you to buy new servers periodically, right? Of course, they want you to periodically get rid of the old stuff and get new stuff in, but also because their costs go up over time. They have to stock all of those parts, and as time goes on, they want to start flushing out those older parts. They don't want to warehouse parts for servers for like 20 years. If you pay them enough, they will do it, but it's going to cost you a ridiculous amount of money. So generally, between the concept of the bathtub curve, reaching the end of it, or starting to see where that slope kind of comes up at the end of the bathtub curve, parts start to fail more frequently. And then the costs for support on those servers, generally at or around the 5-year mark, is well into where it starts to make more sense to just buy new servers, because you will have paid about as much in support over those 5 years as you will have to have bought the server to begin with. So it kind of makes more sense to just reset the clock, get brand new hardware that resets that kind of bathtub curve, and support costs go back down again. Plus you've got the benefit of being on something new and modern. Now, a few people did raise the point of, well, why not just keep some shelf spare servers and just run those things until they fail? That's a good point, and some places like to do that. A previous employer that I worked for liked to do that, and it was horrible because stuff would fail in the middle of the night and you were totally on your own. If you didn't know exactly what the cause of the fault was, you didn't have anyone to reach out to. And servers generally are really good about diagnostics, but sometimes even that fails and you're left scratching your head. Why doesn't this thing want to boot? Is it a motherboard problem? Is it a CPU problem? Is it a RAM problem? Etc. And so now you're spending a ton of time digging through all these parts, swapping them out, seeing what works and what doesn't. Whereas if you had support on a server, you could call them up and they could walk you through more advanced diagnostics to help you figure out which part had failed. Or sometimes you also just get connected to a tech that's got a lot of experience with that particular model. And having talked to a bunch of other customers, throughout the days and months and years with that same model, they know what the most common failure modes are. You can read them off. Okay, so this is the error code that I'm getting and the thing, these are the symptoms. And they can go, okay, well, 90% chances it's this part because that's what I've always seen. There's some value to that too, because as the saying goes, time is money. You don't really want to have a failure sitting there for a long period of time. You need to get it back up and running. Now, redundancy when it comes to systems as a whole is very important. And that's why I had multiple servers to decom. They all work together in a cluster. And I had the ability to basically turn one of those entire servers off and still have enough resources between RAM and CPU and networking amongst the rest of them to keep everything up and running. But again, as servers get older, the chances of multiple part failures become common. I've seen it before. So if you have two servers that decide to fail back to back, or maybe one of them fails and you're starting to work on getting that one fixed and then another one fails, suddenly now you're kind of up a creek. So long story short, generally 5 years for servers is long enough. To some people, it's just personal preference. It also depends on your business and how much they value uptime and the nature of what those servers do. In my case, those servers did an awful lot for an awful lot of people, and 24/7, 365 operation was required of them. So it made sense to decommission them when we did. And we got our money's worth out of them over the 5+ years that we ran them, for sure. And all things considered, they were very reliable. But I still don't regret spending the money on support, because had one of them failed, that support would have paid for itself. So some more amusing comments and questions that I got on that video. Often was asked, can those servers play Crysis, or are they good for gaming? I guess my philosophy is, anything is capable of playing Crysis if you're patient enough. But those servers are actually not really good for gaming in terms of playing the game on them. Like as a game server, they would do great. But servers aren't necessarily meant for end user operations. They're not really meant to be desktops. Partially for practical reasons, like they're really big and they're really heavy and they're really loud because they're installed in server rooms and data centers where noise doesn't really matter. And then also the power consumption. We talked about that in the video where that IBM server, the X5, each of those power supplies could draw 2,000 watts. You don't want to see your electric bill after running one of those for a while. So from a practical perspective, yeah, I don't think you'd want to use one as like a gaming rig or just, a really high performance desktop for at home. But also from the way they're designed, they're not really meant so much for that use. Now, this has started to change a little bit, but generally servers are meant to run applications in a kind of spread out type of fashion. There are some servers, and in fact, the IBM X5 that we looked at was one of them, where they can be designed and built to run just one thing maximum performance all the way through, right? Like you're just running one service or one application and you just want to get the best performance you possibly can out of it. But increasingly, we've seen servers built more along the lines for virtualization or for running parallel operations where you've got a whole bunch of different stuff all running on the server at the same time. Each of those individual things isn't terribly demanding on its own. Maybe it's a fairly limited or lightweight type of process. Maybe it's just like a web server, like running Apache or something like that, or it's doing some basic infrastructure kind of operations, like it's a DNS server or DHCP server, something like that. Not the kind of thing where the CPU is going to be maxed to 100% all the time, but you pile enough of that stuff on one of those servers and it's going to ramp up the CPU load and it's going to consume a fair amount of RAM. And so the servers need to be kind of built for really good multi-threaded, multi-process type of applications. So that's really kind of where they're going because that's how they're increasingly being used, especially in a virtualized type of environment. And talking about virtualization in general is probably a topic for another podcast because you can go super deep into that. But there are some servers that are built for like that single thread or single purpose type of operation. But the architecture to them is meant more for getting a lot of I/O in and out of the box, again, kind of in that fan out or spread out type of way. When we pop the covers on those servers, I showed you all the different PCIe slots inside of them. But here's the thing, none of those were by 16 PCI slots. Most of them were by 4, and there were a few by 8 slots. And that's because they're not designed for plugging in GPUs. In fact, there are no spare power tails inside those servers to plug into a GPU to give it the extra power that a GPU card would need. Instead, those servers and those slots are designed for things like RAID cards, network cards, host bus adapters. In some cases, you can be throwing in some sort of like flash accelerator cards, that kind of stuff. But generally, it's meant for I/O, getting data into or out of the server, and not so much co-processing, which is what GPUs generally do. Now, that said, there are servers designed to have GPUs installed in them, but again, they're not necessarily meant to be like really powerful gaming rigs that you can run whatever first-person shooter you want on them and get like 10,000 frames per second. But rather they're meant for offloading tasks to the GPU for acceleration. Things like CAD design or video rendering or in some cases VDI, getting better graphics out of virtual desktops if you have to use those at work. I'm not the biggest fan of VDI myself, but you can throw video cards and servers for that to try and get better visual performance, but generally you're not going to be hooking monitors up to the backs of cards, of video cards inside servers like that. They're going to be used for offloading tasks too. They're going to sit there, grind away for a while, and then come back. And that's kind of like a parallel with the whole crypto mining thing where people would offload crypto mining to GPUs. When people would do that, they didn't really care about how fast the PCIe bus was because it's just giving that task to the GPU to run internally and then come back with results. You don't have a whole ton of bandwidth that needs to go back and forth between the card and the CPU, which would necessitate faster PCIe bus. So generally, no, they're not good for a desktop or for gaming. You could use one as a desktop if you want to. I mean, they do come with onboard graphics, but it's really lame. You could just throw a card in there if you don't care too much about performance and actually use one, but I think it would be an exercise in frustration. You'd be better off just building like a good desktop system. And for the amount of money you would pay to build a good gaming desktop versus buying even a used server that's a few years old and outfitting it for gaming, you'd have a much better experience with the gaming desktop for sure. Also, some questions about nomenclature and acronyms and that sort of thing. The first thing is a few people wanted to give me crap about the term DOM, D-O-M. I defined it in that video as disk on memory. Some people jumped in there, gave me crap about, no, it's disk on module. I think it's one of those, like, what does the R in RAID stand for types of deals. Nobody's wrong, nobody's right. It is what it is. Basically, a DOM is simply storage that's on a module or flash memory that plugs into something like USB directly on the motherboard instead of being in a traditional hard drive format like a mechanical drive with spinning platters or an SSD, something like that. They're generally going to be very small capacity and meant for reading periodically, but not doing a whole lot of writing too. Like I showed in that IBM X5 when we popped the cover, that machine booted from a USB DOM. It was effectively a USB flash drive. And that's because the particular software, VMware ESXi, works great in a scenario like that because it reads from that drive generally once when you boot the server up and then never really needs to touch it that often ever again. So DOM, disk on module, disk on memory, whatever. The other thing that people were questioning was I had mentioned that all of those servers, because they ran virtualization, were connected to a SAN, and some people were like, no, you mean a NAS. There's actually a difference between SAN and NAS, and not just the order of the letters. It also has to do with the use case and the scope. Now, there is some overlap between the two, but generally the scale is kind of what defines them. A NAS, or network attached storage, is generally going to be more user facing, where it's going to be something like a file server where people can access from their own computers, their workstations, their laptops, and read files from, write files to. It's just like a big file server you can store all your work on and collaborate with others and that sort of thing. And it's just attached to the network, as the acronym says, for you to be able to reach it from all over the place. Now, a SAN, storage area network, is going to be typically a different use case. Some SAN systems can present file shares for end users to use, but the majority of them are meant more for back-end block storage. What I mean by block storage is basically the SAN pretends to be a hard drive for another computer, as opposed to being a file server that the other computer connects to and can read and write individual files from and to. So with a SAN, you're going to be using protocols like Fiber Channel or iSCSI or NFS, and you're going to present that to another server that doesn't have that storage on board. And when you do, that other server is just going to see it like a hard drive. And you can format that volume that gets presented to that server in whatever format you want. If it's a Windows server, you can do NTFS. If it's Linux, you can do one of the flavors of EXT, or you can do ZFS, or whatever you want. The back-end SAN system just treats it all as ones and zeros. And you can compartmentalize that however you want. You can say, okay, well, my SAN has 20 terabytes of storage, and I want to carve that up into a whole bunch of little 1 terabyte chunks to give to one of each of 20 different servers. Or you can slice and dice however you kind of want. And you can also share those disks between multiple servers if they're capable of doing that. VMware is an operating system that is. So I would actually have a whole bunch of different like virtual disks on the SAN, separated out by, what their purpose is and different sizes, but they would all get attached to the same servers at the same time so that they can share those resources, and some virtual machines from one server can be moved to another one on the fly and that all kinds of stuff. So generally, that's kind of the split. With a SAN, it's going to be block storage. It's going to be acting like a hard drive for a server, whereas NAS is going to be file storage that's more end user based. Like I said, there's some kind of gray area between them. SAN systems can present file shares, and some NAS systems are capable of presenting block storage, like the Synology systems, like you may buy at home or have at work if you work in a smaller environment. They're capable of doing iSCSI, but you don't necessarily get all the same bells and whistles that you would out of a bigger SAN. Now, there's of course also a big price difference too. A NAS, you're going to spend anywhere from a few $100 to a few $1,000 on. A SAN, you're going to be spending kind of like more server type of pricing in the tens of thousands to hundreds of thousands of dollars range. But again, it also comes down to the supportability and the parts availability and the feature set and the reliability and yada yada. Anyway, so generally, that's the big difference. If you've got virtualization going on, you're more likely going to be connecting to a SAN than a NAS. But what are the other workloads that big servers like this can do? And that's kind of the last question that I've got that was frequently asked is, I mean, so virtualization, that's a big thing for, big servers like this, but what other workloads could be run on them? And the biggest thing that I can think of is going to be high performance computing, HPC, or running something like a database. HPC is going to be more of like a distributed workload where you've got like a really, really big data set that needs to get chewed on. Maybe it's doing some sort of scientific analysis or something like that. If you've ever heard of like folding at home, in some ways, that's a great example of HPC. But all of the modern like supercomputer clusters these days, that's HPC, where you take a whole bunch of individual servers and you spread the workload amongst them and kind of get them to each take a chunk of it. Instead of trying to scale out and building one single big massive server that's got like 1,000 CPUs or whatever directly in it, you buy like 1,000 servers that have 1 or 2 CPUs in each of them. And you just break up that work to each one of them. And you've got some servers that kind of coordinate how all that happens. So that's a great use case for big servers like this, where, maybe they're doing some of that like statistical analysis or scientific purpose or, whatever, where you've got like a lot of just data that needs to get crunched that's ultimately part of one big set, but can get divvied up into smaller pieces. The other thing is for kind of more practical purposes. A lot of those bigger servers were often run as database servers, where maybe you have reports that need to get run, and there's a whole bunch of data that needs to get churned through and sliced and diced and put together and calculated and all that kind of stuff to come up with the pretty 5-page PDF report that gets handed to the CEO that says, this is how our business is doing this year or whatever. A lot of times people will skip virtualization for really big databases like that and run them, directly on the server. And the IBMs are actually a really good example of that. I kind of skipped over this part in that particular video, partially because I forgot to talk about it, and also partially because that video was kind of going on long enough as it was. But some people in the comments pointed out that the IBM X5 that I showed has QPI ports on the back. And that's an interface that IBM had on some of its servers where you could basically link the servers together and get them to perform as one unit. So kind of like that whole HPC concept, but you don't need to put quite as much into it to get it to work. So you could have, one server that's got like 1 terabyte of RAM in it and 4 CPU sockets. If you took another one of those and linked them through those QPI ports, it would then show in your operating system you've got 2 terabytes of RAM and 8 CPUs. It would just kind of scale out like that. There were definite limits as to how far you could take that. But for something like running just a big, massive database or doing a whole bunch of number crunching, that was a pretty valid option as well. So while I think on larger servers, virtualization is going to be by far the primary, primary use case, what people are primarily going to be running on them, there are still some other purposes where people are going to be putting them to kind of a single task. And that's why I think those really big 4-socket servers are still being sold. They're not common. There's really only a few models out there on the market, but they are still available and people do still buy them for their own purposes. So, I think big servers are going to be sticking around for a while yet. Anyway, I am curious as to your thoughts. Do you have any subsequent questions? Hopefully this answered the majority of the most common ones. Do you have experience working with these servers? What are some of your stories? How are you doing it? Do you have some horror stories of dealing with these kinds of things where you wish you had designed your setup differently? Maybe these servers in the end didn't work out for you and you wished you had gone with many smaller ones, which is actually what I ended up doing at my work. I mentioned at the tail end of that video that instead of doing 4 really big servers, we scaled out to 6 kind of medium-sized servers. Gives us a little bit better protection, a little bit better bang for buck that way. Have you learned that same lesson, or are you consolidating down things even further? I'm just curious as to your thoughts, so be sure to leave them down in the comments below. Also, if you're interested in audio-only versions of these podcasts, I have them available for Patreon supporters at all contribution levels. As little as $1 a month gets you access, and they go up as plain MP3 files you can download. There's also private RSS feed support. Throw that into the podcast player of your choice. They'll show up automatically. And the episodes do usually go up a few days before they're here on YouTube, so it's just something to think about. Anyway, if you like this one, I would appreciate a thumbs up. Be sure to subscribe if you haven't already. You can follow me on Twitter and Instagram at thisdoesnotcomp. And as always, thanks for watching.